Okay, and our next speaker is Ulrika Malá, coming from UCT Prague. The floor is yours.
Oh, I see. Okay, great. So, ladies and gentlemen, I would like to present you the topic of analysis of the human scent on the cartridge cases using GC/GC-MS TOF. So, beyond the obvious motivations to be able to implement those techniques in the forensic practice, the previous studies that led to this experiment were the thermostability of the scent. That means that there is a part of the scent that survives even the heat of 500 degrees of Celsius for 1 minute. And it seems like it is the most significant part for the individual identification. So, in together, it looks like that this part of the scent could remain on the cartridge cases even after firing the gun. So often you can find on the crime scene cartridge cases with a dactyloscopic fingerprint. Unfortunately, it is often partial, so there is not enough minutiae to be able to do proper individual identification. So the scent could be a suitable alternative to do a proper individual identification of the shooter. So in this pilot study, we built a simulated crime scene with 4 volunteers, and one of them was our shooter. And we obtained 3 scent samples from each volunteer on the glass beads, as we normally do. And then we have 4 unknown samples on the cartridge cases. So this is how the simulated crime scene looks like. Of course, Of course, there was a target, the shooter with the gun, and on the left side, as you can see, there were 2 wooden pallets leaning on each other, and on top of it was a plastic sheet. So when the shooter was firing the gun, the cartridge cases were falling into this area, and 2 of them fell on the plastic sheet, 1 on the wooden pallet, and 1 on the concrete floor. So after that, we collect the samples from the crime scene and extracted them into ethanol, as we normally do. And after the measurement on GC/GC-MS TOF, we aligned the data through Kovács retention indexes. And for the calculation, we use the standards as chosen peaks evenly distributed through the first and second dimension. Then we focused only on the source of substances that are at least on one of our unknown sample. And in addition to that, substances that at least on 75% of all our known data. So for the statistical evaluation, we didn't use the quality of the substances itself, but the areas and the area ratios. Then we ordered the area ratios by increasing the volatility, increasing the statistical variance. So we will be focusing on the substances that are more stable in time in the human scent. And for the statistical evaluation, we use only the first 150 area ratios. So as you can see, for the statistical evaluation, we use cluster analysis. And unfortunately, we were not able to link any of our unknown samples to any of our volunteers yet. However, we were able to distinguish the volunteers on the glass beads. So it supports the theory of human scent would be a good forensic tool for individual identification. And the reason why we were not able to identify the shooter could be thanks to the data alignment, because we know it's not perfect, because where we use Kovács retention indexes, we assume that the shifts on the first and second dimension are linear, but in fact they're not. So beyond the GC analysis, we do the comparison by police-trained canines as well. So now you can see how it is done in the Czech Republic. Firstly, the handler will give to the canine a jar with a so-called sniffing sample, and then the canine will be comparing this sniffing sample with the scents in a row. And if he finds a match, he will mark it by laying down, and then he will get the reward, because that's why he's doing it, right? And it's fair to say that the canines were able to find our shooter, so that supports the theory that it is possible. However, with the GC analysis, we are there not yet. So in conclusion, we've shown the ability to distinguish each volunteer on the glass beads, and we were able to find the shooter by police-trained canines. And the surface from which we're collecting the unknown samples doesn't seem to play a significant role for the identification, which is a good thing. And for the future, we can try to equalize the parameters on the glass beads and the unknown samples on the cartridges, meaning that we can heat the glass beads with the human scent on it on the same temperature as it is during the firing the gun. So because the heat could slightly change those substances, so maybe it will be equalizing the parameters, and we will be able to link the the unknown samples to the known samples from the volunteers. Then, of course, we need to shorten the time of absorbing the scent on cartridges because it was a pilot study, and we need to be sure that human scent is present on the cartridges. The shooter was rubbing the cartridge cases for 10 minutes before loading the gun. So in the future, we have to shorten this time for only loading the gun. And then it would be nice if we will be able to do scent and dactyloscopy analysis on the same trains. And lastly, of course, we want to broaden the number of volunteers, various types of gun, ammunition, and so on. So lastly, only yesterday our pilot study was accepted as a perspective in analytical chemistry, so we will be able to check the details soon about the study. And last but not least, my supervisor, Professor Urban, would like to invite you for a second International Forensic Olfactronic Workshop that will be held in Prague, preliminary in winter 2027. So. Thank you very much for your attention, and if you have any questions, feel free to ask.